So when we look at this, we'll start off with the simplest example. Hydrogen only has one electron. And remember we said on Tuesday that when we're looking at the hydrogen box, we're talking about the first electron in any element or the only electron for hydrogen. If I look at the sodium box, I'm talking about the 11th electron, the last electron in for sodium, or it could be the 11th electron in any other element. For our discussion, we will always be discussing the last electron for any given element. It's what we're going to discuss. So for hydrogen, we look at the box on the periodic chart. N is equal to 1 because I'm in the first period and I'm over in the first two columns. L is 0 because I'm in that chunk of the first two columns. So N is 1, L is 0. M sub L for this whole chunk is 0. And M sub S, because I'm in the first column, M sub S is plus 1/2. Now let's look at helium. Remember, helium belongs over here. Okay, helium is not on the right-hand side of the chart for this discussion. So, for helium, N is 1. L is 0 because I'm in the S block, the first two columns. M sub L is 0. And helium is the second electron to go in there, so M sub S is minus 1/2. Now, what do you notice about the quantum numbers for the first and second electron? 3 are the same and 1 is different. So you can have 3 quantum numbers the same for any 2 electrons, but the fourth one has to be different. No 2 electrons can have the same 4 quantum numbers. They cannot occupy the same space. And remember, this is just kind of telling us what the electron's address is. When you think about this, if you wanted to come over to my house and have a spaghetti dinner chemistry study party, I used to do that, but now they don't. They frown on that here now, so we don't do that anymore. But go figure. Anyway, if you want to come over there, you'd say, well, where do you live? And I would say, well, I live in Saginaw. So that is like N. N is the principal quantum number. I live in Saginaw. It tells you which of the 3 counties in the Delta District I live in. Then you say, well, where in Saginaw exactly do you live? Well, now it's L. Which subshell? Which section of Saginaw do I live in? I live near Hospital and McCarty Roads. Okay, that narrows it down. Then M sub L. What street do you live on in that subdivision? I live on Scenic Drive in that subdivision at the corner of Hospital and McCarty. So that's M sub L. Which orbital? Then M sub S is the house number. So M sub S is a spin, and that narrows it down. If I tell you my house number, now you know exactly where I live because there are lots of houses on Scenic Drive. And so it's just like the electron's address, and we narrow it down the more quantum numbers we know. Now let's look at lithium. What is N for lithium? 2. What is L? 0. M sub L? 0, and M sub S, plus 1/2. Now look at the quantum numbers for hydrogen and lithium. What do you notice? They're all the same but 1. The difference is the principal quantum number here. So these are in the same family. So L, M sub L, and M sub S are all the same. Now let's look at boron. Boron is over here. So it's in the second period. We're in the P block. So N for boron is 2. L is 1 because I'm over here in the P block. M sub L. Remember, minus 1, 0, 1, minus 1, 0, 1. So it is minus 1. and my spin quantum number, m sub s, is plus 1/2. Now let's look at oxygen. Oxygen's over in the p block, so n is equal to the period number 2. L is 1, m sub L, -1, 0, 1, -1. So what is m sub s? -1/2. So now looking at boron and oxygen, what do you notice? The first 3 quantum numbers are the same, but the last one is different. The spin is different, so those 2 electrons are sharing an orbital. They're orbital mates. Okay, now let's move to the D block and look at iron. So iron is in the 4th period, and the principal quantum number in the D block is n-1, so n is equal to 3. L is 2, 0, 1, 2. M sub L, -2, -1, 0, 1, 2, -2. And m sub s is what? -1/2, because it's the second electron to go in there. Okay, let's look at tungsten down here. I don't like this periodic chart. It kind of messes things up because it has these extra boxes in here. Oh, no, I guess it's okay because it just has lanthanum in 2 places, and we said we'll ignore it down here. All right, we're okay. So when we look at tungsten, tungsten is in the 6th period, so what is N? 5. What is L? 2. M sub L, -1 or -2, -1, 0, 1. And what is M sub S? Plus 1/2. Why is tungsten W? W. It's from the Latin name wolfram. Doesn't that seem like a weird name for an element? It got the name wolfram because when tungsten metal is molten, it gets real foamy. And someone said it was like the spit of a wolf. They called it sponolovium, the spit of the wolf, and that's how it got the Latin name wolfram. So I always think of that. It's kind of weird. I've never seen molten tungsten in person. I have seen a video, and it does look foamy, but I've never seen wolf spit up close and personal, so I'm not sure it really looks like that. Okay, cerium. Cerium is down here in the F block, so remember, we're just ignoring this. 58 goes up here in the 6th period, so N is equal to 4 because we're off by 2 in the F block. L is 3. So M sub L, we start counting here, -3, -2, -1, so it's -3. We're the first one in, so it's a plus 1/2. So now, even if you don't really get this whole theoretical idea of standing waves and orbitals and naming them with quantum numbers and using calculus to derive the shapes, can you get how to assign quantum numbers from this? It's really not bad as long as you got the chart in your hand, which you will. So we'll stop here and just have you take some time working at your seats to go ahead and fill in the rest of those.